Okay, this is part 3, and in part 3 we're going to use our special triangles to find some exact values, and then we're going to solve a simple trig equation. To start, it says draw an angle theta, which is pi over 6, as an angle from standard position, and determine the exact values of each angle under the 3 primary and 3 reciprocal trig ratios. So to do that, I'm going to draw my Cartesian plane, and I'm going to label it here with the angles in radians to kind of help us graph where this pi over 6 angle is going to be. Standard position is 0. 1/4 rotation would be 90 degrees, but in radians that's pi over 2. 1/2 rotation is going to be pi, because that's 180 degrees. 3/4 rotation is 3 pi over 2. 3 over 2 is 1.5, so it's 1.5 pi. So we've got half pi, 1 pi, 1.5 pi, and a full rotation would be 2 pi. So this will kind of help us get a foundation for where this pi over 6 angle is going to be. So let's think, where is pi over 6? Well, pi over 6 is a fraction. If we ignore the pi, that's 1 over 6. And 1 over 6 would be somewhere between 0 and 1/2. Right? It wouldn't be all the way to 1. It would be smaller than a half. A sixth is smaller than a half. So pi over 6 is smaller than pi over 2. So that means we have an angle in the first quadrant. And if we draw our triangle, this is our pi over 6, pi over 3, pi over 2 special triangle, or in degrees it's our 30, 60, 90. Now we got to think, is pi over 6 30 or 60? Well, pi divided by 6 is bigger than pi divided by 3. Sorry, is a smaller number than pi divided by 3, so that means it's the smaller of the two, 30 or 60, so this is the 30-degree one. So if we label the triangle, this is 1, root 3, 2. And since we're in the first quadrant, our x is positive, our y is positive, our radius is always positive. So if we want our sine, cosine, tan, well, sine pi over 6 is opposite, which is your x, over hypotenuse, which is your r, so it's 1 over 2. Cosine pi over 6 is x over r, or adjacent over hypotenuse. In this case, the x is pi over 3, and the hypotenuse is 2. For tan, we got opposite over adjacent, or y over x, which is 1 over root 3. And to rationalize that, we'd multiply top and bottom by root 3, and we'd end up with root 3 over 3. To get our reciprocals, the reciprocal of sine is cosecant. Cosecant pi over 6. Flip that fraction, we get 2. The reciprocal of cos is secant. Flip that fraction, we get 2 over root 3. And to rationalize, multiply top and bottom by root 3. We get 2 root 3. And root 3 times root 3 is just 3. And our last one is cotan, which is the reciprocal of tan. So that means flip tan. If you flip the original one, you just get root 3 over 1, which is something we don't have to rationalize after, so I'm just going to do that, and we get root 3. So here's your 3 primary ratios and your reciprocal ratios. Example 2 says determine the exact value of each trig ratio. I'm going to do one example, and then I'll leave the second example for you to try, and you can check your answers on the course website. So here we go. We want the exact value of 5 pi over 4. So I'm going to draw my Cartesian plane. And I'm going to graph the angle 5 pi over 4. So I have to think, in what quadrant is 5 pi over 4 going to end up? Well, a half rotation, or 180 degrees, is pi, and a 3/4 rotation is 3 pi over 2, or 1.5 pi. 5 over 4 works out to 1.25, which would be between 1 pi and 1.5 pi. So that would put my angle right here in quadrant 3. In order to find the exact value, we have to figure out what the related acute angle is in this triangle so we can use our special triangles. And our related acute angle would be our principal angle, subtract pi, or 5 pi over 4, subtract pi, to see how much we have left over for this little piece here in this triangle. Well, if we subtract a pi from 5 pi over 4, pi as a fraction over 4 would be 4 pi over 4. 5 pi over 4 subtract 4 pi over 4 is 1 pi over 4, or just pi over 4. And that's a special triangle. That's our 1, 1, root 2 special triangle. And now in order to get the proper exact value, accounting for what quadrant we ended up in, we have to think about whether x and y are positive or negative in this quadrant. Since we're in the third quadrant, x is to the left, which is negative, and y is down, which is also negative. So we have our x and y's as negatives. And now if we just use this related acute angle and the properly labeled triangle, we can come up with the exact value of cos 5 pi over 4. Cos 5 pi over 4, cosine is adjacent over hypotenuse, or x over r, which is negative 1 over root 2. And if we rationalize that, we get negative root 2 over 2. To confirm this, we can check it using our calculator in radian mode. And you've always wondered what radian mode was. Well, here we go. Check using calc in rad mode. So here we go. Here's my calculator. Turn it on. You can see the little mode there. If it's in degree mode, it'll be D. If it's in gradians, it'll be in G. We want it to be in R. So you got to change the mode on your calculator if you're not in radians. And here we go. If we type in cosine of 5 pi divided by 4, we get negative 0.707 approximately. So cos 5 pi over 4 gives us negative 0.707. That's a decimal. We got an exact value. So the advantage of using the special triangles and actually graphing it on the Cartesian plane is to get the exact answer. This is the exact answer. This is the only way to come up with the exact answer. This is an approximate answer. We don't want an approximate answer, but we want to check if our exact answer is right. So how do we do that? Well, we check to see if this equals this. So let's put this in our calculator. Negative root 2 and divide it by 2 and see what we get. What is it approximately equal to? Well, negative root 2 divided by 2 is negative 0.707, exact same decimal. So we did it correctly. And that's using your calculator in radian mode. Try the cosecant question. You'll be able to do the entire process the exact same way, but when you want to check it in your calculator, for your check, you might want to remember that cosecant is not actually a function on your calculator. So to evaluate it, you have to use its reciprocal, which is sine. So it's actually equal to 1 over sine 11 pi over 6. So this is what you'd have to punch in your calculator to get your value. And then you can compare it to what you actually get by using the process. Okay, so try that one and then watch to see how to solve a simple trig equation, which is the last question, example 3. All right, on to example 3. If tan theta is negative 7 over 24, when our angle is between 0 and 2 pi, evaluate theta to the nearest hundredth. Well, we have to ask ourselves, where is tan negative? And according to the cast rule, and do the cast rule over here, CAST, tan would be negative here and here. So the answer is in quadrant 2 and quadrant 4. So we need 2 answers, one in quadrant 2, one in quadrant 4. So let's start by doing quadrant 2. So that means our theta has brought us somewhere into quadrant 2. And what we know about it, our point, negative 7 over 24, represent the opposite side, 7, and the adjacent side, 24. Opposite, our angle beta, would be our 7, and adjacent would be our 24. and one of them has to be negative. Well, 7 being up is definitely not the negative, but 24 going to the left is our negative. So here's our 1, and if we want to find out what beta is, we can do a little trigonometry, because we know that tan beta, beta being a small angle, we can drop the negative signs, would give us opposite 7 over adjacent 24. And if we do tan inverse of 7 over 24 in radians, we get an angle, beta, in radians, which is 0.284 if we go to 3 decimals. Let's just go to 2 decimals. 0.28 approximately. So we've got a small angle, 0.28, and we've got our large angle, theta. Well, a whole rotation to this line would be pi. But we end up this much, 0.28, short of pi. So our angle theta would be approximately equal to pi minus 0.28. And pi as a decimal is 3.14. Subtract 0.28, we end up with 2.86. That's our first theta. Our first angle from standard position would fall up 0.28 radians short of pi. So we do pi minus 0.28 and we end up with 2.86 radians. Our second answer is in quadrant 4, but some of the work will already be done for us. This is our theta. We'll call it theta 2. But the nice thing here is we've already solved for our beta. We know our beta, our related acute angle, is going to be the same in this triangle, 0.28. So we don't have to do any of that extra work. We can label the triangle if we want with -7 for our opposite and 24 for our horizontal, opposite over adjacent. But since we already know the related acute angle, we don't have to do any math here. We just have to think logically, what is this theta 2? Well, it almost goes all the way around, and all the way around would be 2 pi. So theta 2 is 2 pi, but we're short by our beta 0.28. 2 pi is 2 times 3.14, which is 6.28, minus 0.28 is just 6.00. So we end up with 2 answers, 6.00 and 2.86. And if you test that, you'll get approximately, since we rounded, whatever decimal -7 over 24 is. And you can test them in your calculator and you will end up with those values. That's how we can solve a simple trig equation. We're going to do more work with solving trig equations in our next unit, but these are all the skills that we did in grade 11. But these skills now we're revisiting in radians. So we're going to try some example problems in class tomorrow, and we'll do a warm-up as well, and we'll try to wrap our head around the concept of radians and solving for principal angles. Thanks for watching, and I'll see you next time.